Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungudi, MSc MPhil Mathematics, your math tutor from CD King Higher Secondary School, Jotsama, Kohima. In this session, we are going to learn second order derivatives. Let y equal to fx be a differentiable function, right? Then we define the first order derivative as dy by dx. These are called first order derivatives. Okay. First order derivative dy by dx or f dash of x or y dash or y1 or dy. In any way we can represent the first order derivative. Okay. Now if we differentiate this dy by dx again with respect to x, second time, no, that gives us second order derivative. Okay, second order derivative d squared y by dx squared, that is, this will become f dash of x, or you can write it as y double dash or y2 or d square y. Okay, these all represent the second order derivative. There is nothing but we differentiate y twice. Alright, okay. And we can define the higher order derivatives further. You can find the third order, fourth order, or to the power n, we can do it. But in class 12 level, we have till up to second order only. So we will see some problems from your exercise, how to find the second derivatives. This is a very important topic. Every year there used to be a question from this exercise. Okay, the first problem is x square plus 3x plus 2. We have to find the second order derivative. Alright, so let us take this one as y equal to x square plus 3x plus 2. It's a polynomial. So we differentiate with respect to x. We get dy by dx, or you can put y dash, no problem. So x square we differentiate term wise because all are in addition, and x square differentiation is 2x plus 3x derivative is 3, right? Plus this 2 is a constant, it becomes 0. So it is 2x plus 3. And again if you differentiate this dy by dx with respect to x, we get d square y by dx square. So that is equal to, we differentiate this one with respect to x. So 2x differentiation is 2 plus 3 is a constant, so it becomes 0. So this is the second order derivative. This is how we get the second order derivatives of the polynomial. Then there is one more question, that is e to the power ax cos 3x. So let us assume this one as y, e to the power 6x cos 3x. Alright, so differentiate with respect to x, we get dy by dx is equal to, here there are two functions in the product, right? So this is one function and this is another function. So we have to use the product rule or Lebenize rule. So what is that? uv whole dash is equal to uv dash plus vu dash, right? So u is here e to the power 6x and v is cos 3x. Okay, so I'm going to do it straight away here. So you keep it constant, e to the power 6x into, and then v dash is differentiating this one. So cos derivative is minus sine, so minus sine 3x into 3, because we have to differentiate this 3x again. Alright, so chain rule. So minus sine 3x into 3, then plus, keeping v constant and we differentiate u. So what is v? Cos 3x. So cos 3x into u dash. U dash is, we have to differentiate this one. So e to the power x derivative is e power x. So it will be e power 6x into, then we differentiate 6x again. Chain rule. First we differentiate e to the power x, then we differentiate the power 6x. So that is 6. Okay, by differentiating 6x, we get 6 here. So here in this 2, we have common factors e to the power 6, 3 times e to the power 6x. So what is left in the first term? Minus sine 3x here plus 2 cos 3x. Okay, minus sine 3x plus 2 cos 3x, because I have taken this e to the power 6x and 3, e to the power 6x, and from here 3 I have taken out, so 2 left. So 2 cos 3x. So we will differentiate further with respect to x to get second order derivative. So differentiate with respect to x, we get d square y by dx square. So that gives us, here again this 3 is a constant, so let me keep it outside, okay. And here again product of two functions, this is u and this is v, okay, this is u and this is v. Alright, so we differentiate by using this rule, Lebenice rule. So you keep constant first, e to the power 6x into, we have to differentiate this bracket, okay. So minus sine 3x, differentiation is cos 3x into 3, right? Differentiating 3x, we get 3, okay. Then plus, here 2 is a constant and cos 3x derivative is minus sine 3x, so plus of minus is minus, so minus sine 3x into 3, okay. So this is the bracket, we have differentiated this part, okay, plus u v dash plus v is minus sine 3x plus 2 cos 3x into u dash, we have to differentiate this u e power 6x, so that is e power 6x into 6, okay. So close the bracket. This 3 is common for all the terms here, alright. Now we will simplify to get the book answer. D squared y by dx square will be 3 times, and here in these two 3 we have common, right? So we can take it out. So 3 times e to the power 6x, e to the power 6x in bracket we have minus cos 3x minus 2 sine 3x. Alright, so we have taken the 3 outside. So we have cos 3x minus 2 sine 3x. And in the second term, if we can write this 6 e to the power 6x in front of the bracket, then inside the bracket we have minus sine 3x plus 2 cos 3x. Okay, close the bracket. Okay, now here in these two, from here 3 e to the power 6x we can take common. So 3 times 6 e to the power 6x, if you take outside, then what you have here, minus cos 3x minus 2 sine 3x. Here we have taken 3 e to the power 6x, so 2 remains, right? So that 2 you multiply inside. So minus 2 sine 3x plus 4 cos 3x. Okay, then this is 9 e to the power 6x. So inside the bracket we simplify. So if we simplify these two, 3 cos 3x, and if you take these two together, minus 4 sine 3x. So this is the required answer. This is our second derivative. Our third problem is log of log x. Okay, so here also we have to find the second order derivative. So let us take this one as y. So let y is equal to log of log x. Alright, so differentiate with respect to x, we get dy by dx is equal to, derivative of log x is 1 by x, right? So this one, if you treat it as x, so derivative of log x is 1 by x, isn't it? So 1 by log x into, then we differentiate this part by using the chain rule. So if you differentiate log x again, you get 1 by x. So this I'm going to write it as x log x whole to the power minus 1. Minus 1, easy to differentiate the second order derivative. Okay, so this is in the denominator, so I brought it to the numerator to the power minus 1. Then we differentiate with respect to x, we get d square y by dx square. We have to differentiate this part, right? So here, first we differentiate the power and then we get inside the bracket. Okay, so the power of differentiation is minus 1 into x log x to the power minus 1, isn't it? Into, now you get inside the bracket. Here x log x, there are these two are in multiplication, product of two functions, right? So here again we use that Lebenize rule, uv whole dash is equal to uv dash plus vu dash. You keep this one constant, differentiate this, and keep this constant and differentiate this one. So x into differentiation of log x is 1 by x plus, keep this constant now, log x into differentiation of x with respect to x is 1. So these two gets cancelled. So what do we get here? Minus 1. This one I can put it in the denominator, x log x whole square, right? And here we get 1 plus log x. So this is our book answer, the required answer. Okay. The next problem is, if y is equal to 3 times cos log x plus 4 times sin log x, then prove that x square y2 plus x y1 plus y equal to 0. So we have to bring out this equation. This y2 represents the second derivative, second order derivative, and y1 is the first order derivative. So we find out first these two derivatives, then we substitute in the equation to get 0. So differentiate with respect to x, the given function, we get, let us use y1 here instead of using dy by dx, because in the proof we have to bring y2 and y1. So I am writing this first order derivative as y1, that is equal to 3 times, 3 is a constant and it is in multiplication, so it remains the same. And cos, derivative of cos is minus sin x, therefore I put the minus here, minus sin log x into derivative of log x is 1 by x. Chain rule here, 1 by x. First I have differentiated this cos and then log x. Plus 4 is a constant, so let it be the same. And derivative of sin is cos. So cos log x into derivative of log x is 1 by x. Okay. Here x is in the denominator for both the terms, so we can take it as common denominator and I will bring it to the left side. So it will be x y1, that is equal to minus 3 sin log x plus 4 cos log x. Since x is the common, 1 by x is the common factor in both the terms, if you take it outside and then bring it to the left side. Okay. Then we differentiate this one with respect to x. Differentiate with respect to x, we get. Alright. So here in the left side, product of two functions again, isn't it? UV method we have to use. So let me keep x constant and differentiate y1, we get y2 plus keep y1 constant and then differentiating x you get 1, isn't it? So 1, that is equal to minus 3, derivative of sin is cos, so that is cos log x into 1 by x plus chain rule. First we differentiate sin and then we differentiate log x. Then we move on to the next term. 4, derivative of cos is minus sin, so plus of minus becomes minus. So sin log x into 1 by x. Here also we get in the denominator in both the terms x. So we can take it as common and bring it to the left side. So it becomes, when you multiply here, it becomes x square y2 plus x y1. Alright. And here minus 3 cos log x minus 4 sin log x. So can we take minus from both the terms? Yes. So this will be 3 cos log x plus 4 sin log x. And here it is nothing but our y. It is given in the question, right? So 3 cos log x plus 4 sin log x. So we can replace this with y and bring this y to the other side. So you get x square y2 plus x y1 plus y is equal to 0. So hence proved. Okay. Otherwise here, instead of bringing this x to the left side, you can just keep it y1 like this, and then if you differentiate with respect to x, here it will be complicated because it will be u by v method, okay, because this is u and v, quotient rule you have to apply, then it becomes more complicated, okay. If you want to try that way also, you can try, you will still get the proof. Okay. The next problem is, if y is equal to a e to the power mx plus b into e to the power nx, show that d square y by dx square minus m plus n times dy by dx plus m on y equal to 0. So we will find out dy by dx and d square y by dx, then substitute in the left side to get 0. Okay. So here, if you differentiate with respect to x, we get dy by dx is equal to, a is a constant, e power x, differentiation is e power x into m, because derivative of mx is m, then plus here b e to the power nx into n. Alright, then d squared y by dx square, differentiate again, we get a e to the power mx into, again one more m we get, into m, so it becomes m square, plus here we get one more n, so we get n square. Okay, then let us take the LHS. LHS is d squared y by dx square minus m plus n into dy by dx plus mny. Okay, let us substitute these values, that is m square a e power mx plus n square b e to the power nx minus m plus n into dy by dx. dy by dx is here, m into a to the power, a into e power mx plus n b e to the power nx plus mn into y. Y is a e power mx plus b e power nx. If we simplify this, we get 0. So here m square a e to the power mx plus n square b e to the power nx. Then I multiply m with these two terms and then n with these two terms. First let me multiply this m with the two terms, minus m square a e to the power mx, then minus into plus minus m n b e to the power nx. Okay, now with n, mn, here minus is there, so it becomes minus mn a e to the power mx, then minus into plus minus n square b e to the power nx. And if you multiply this mn inside, mn a e to the power mx plus mn b e to the power nx. You will find all the opposite terms. M squared, these two gets cancelled, and here these two gets cancelled, and here these two opposite signs, and here these two opposite signs. So all gets cancelled. So we get 0. So hence proved. This is the end of differentiation of second order derivatives. With this concept, knowledge of the concept, you can do the remaining problems in the exercise. In the next session, we are going to learn applications of derivatives. Thank you.